I'd like to sketch a graph of this ellipse, and in so doing we'll find all the important points also. The problem here is this does not in any way look like something that I know what to do with. I can tell it's an ellipse. X is squared, y is squared, x and y are both positive, they're added, and yeah, that's about what I can tell. So I can tell it's an ellipse, but I can't tell where anything is. So we're going to have to fix this equation and try and put it in standard form. The way we're going to do that is by completing the square. So I'm going to put my x terms together and my y terms together, just for optical purposes, easier to see them. And I'm going to go ahead and put my 23 on the other side. I'm going to add 23 both sides. I know the standard form of an ellipse has equals 1, so my constant's going to be on the opposite side of the equal sign. Okay, completing the square. Here's the thing about completing the square. In order to complete the square, the leading coefficient, the coefficient of the x term, has to be 1. It's not. To complete the square with y, the leading coefficient of the y's has to be 1. It's not. It's a 9. So we're going to have to fix that before we can do anything else. But we can. The way we're going to fix it is by factoring. I'm going to factor 4 out of both of my x terms. And I'm going to strategically leave a little room there. I'm going to factor, it looks like I can factor 9 out of both my y terms. And I still have equals 23. So I haven't changed anything. Factoring doesn't change. If I multiplied the 4 and the 9 through, I'd have exactly what I had before. It just looks different. It's in a better form for what we're trying to do. Okay, completing the square. Coefficient of the x term is 2. 2 divided by 2 is 1. 1 squared is 1. Coefficient of the y term is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. Now we just added some stuff on the left-hand side of this equation, so we're also going to have to add stuff, the same things, on the right-hand side. For the x's, I put a plus 1 right here, but the thing is, I didn't just add 1. That plus 1 is inside a set of parentheses that has a 4 distributing through it. So I didn't really add 1, I actually added 4 for the x's. Same thing with the y's. I put a plus 1 right here, but that's inside a set of parentheses that has a 9 distributing through. So 9 times 1, I actually added 9. Good thing about completing the square, guaranteed we're going to factor when we're finished. So this is 4 times, that's x plus 1 times x plus 1. And 9 times, and that'll factor as y minus 1 times y minus 1, equals 23 plus 4 plus 9, sounds like 36 to me. This is better. I can at least tell where the center is going to be, but it's not quite standard form yet. Standard form for an ellipse has a 1 on the right-hand side of the equation. Right now I have a 36. So we have to fix that. And the way we're going to fix it is dividing everything by 36, because if I divide on the right by 36, I better divide everything else by same so that equality still holds. Now I got my equals 1 on the right, 36 divided by 36, and we'll just think reducing. 9 divides into 36, 4 divides into 36, and it looks like we have x plus 1 squared over 9. And y minus 1 squared over 4. Well, that's better. I can at least tell what's going on now. So next thing I'm going to notice here is the center. The center, that's x minus negative 1, y minus 1. My center's at negative 1, 1. A, for an ellipse, is the bigger value. So 9 is a squared, which means a is 3. I can also tell from that, since my bigger value is with the x term, My major axis is going to be parallel to the x-axis, is going to be horizontal. So to find the vertices, I'm going to go a distance of A, a distance of 3, to the left and to the right of the center. And there are my vertices. Let's see. So I went left and right, -1 plus 3, -1 minus 3, and there are my two vertices. B squared is with the y term then. If b squared is 4, then b is 2. And that's going to help us find the endpoints of the minor axis. I'm going to go from the center parallel to the y-axis vertically, a distance of 2. My minor axis endpoints then are at -1, and then from 1 I went up 2, and from 1 I went down 2. That's enough to sketch a graph. We are going to go ahead and find the foci though, just because we can. For the foci, we get a squared equals b squared plus c squared. In an ellipse, a is the biggest one. Well, a squared is 9, I can tell from the equation. B squared is 4, I can tell that from the equation too, which means c is the square root of 5. Square root of 5 is a little bit more than 2. You don't need to cut it any finer than that, so I'm going to go from the center along the major axis, that'll be left and right, a distance of the square root of 5. Something like that, a little bit more than 2. Coordinates of my foci, I went from -1 to the right, a distance of root 5, and to the left, a distance of root 5, and there are my foci.